All right, up until now in this series of videos, you have been given the divisor to divide into the polynomial. However, if you really just need to figure out what the zeros of a polynomial are, you might be guessing forever and ever and ever what the zeros might be. So the rationals zero theorem helps us narrow down the number of possible zeros without getting into a lot of the nitty-gritty of this all. If you want to pause the video and read through it, there's an example here of why this rational zero theorem works. However, I want to skip down more into what we need to look at. All right, so the rational zero theorem says that you need to find all of the factors of, notice here it says A naught and A sub n. So your constant term at the very, very end, your y-intercept, if you will, and your leading coefficient. You need to find all of the factors of both of those. Every rational zero of f is going to be one of the factors of the constant at the end over one of the factors of the coefficient at the very, very beginning. When your leading coefficient is 1, we're just going to look at the constant term. And since they're rationals, we have to consider both the positive and the negative of each and every factor combination. All right, let's look at what that actually means in practice. So I have 2x to the fourth minus some stuff in the middle, and then minus 4 on the end. So I need to figure out what are all the factors of plus and minus 4. Well, that is plus and minus 1, plus and minus 2, and plus and minus 4. Don't really worry about the signs of this one because we're going to end up doing all the positives and negatives eventually, but you just need to make sure that you know right away, like, okay, I'm looking at 4 and I need to remember it's the positives and the negatives of all of the factors of 4. All right, let's look at our leading term, 2. And I have 1 and 2 here. Therefore, I would have 6 combinations on top of 1 because I have both the positive and the negative. So I'm going to write those just as the 3 combinations. But remember, those are 6 different combinations over the 1. And then 6 different combinations over the 2. And rather than having an infinite number of ways we could look at this, this is going to help us narrow down where we should start. We're also going to assume that we're going to be doing linear terms because some synthetic division. And the big goal then is to get a remainder of 0. And then we know that that is the factor. Let's look at an example of that so you can see that in practice. All right, so find the zeros of this cubic function. Notice if it was quadratic, I might want to try to do like quadratic formula or try to factor or something of that nature. It's not, it's a cubic function with no quadratic term. So I need to try to figure out all the possible zeros. Okay, so I like to always write my end with plus or minus 1. And that's it, right? It's just plus or minus 1 down here. All right, let's look at 4. I might have 1, 2, or 4. So all my possible combinations are plus or minus 1 over 1, plus or minus 1 over 2, and plus or minus 1 over 4. Let's start with positive 1 and just see what happens. So my goal with starting with positive 1 is that I am going to get a 0 as my remainder. Then I know c equals 1 or x equals 1 is one of my zeros. Also notice in my synthetic division, I don't have an x squared term, so I do need that placeholder. Otherwise, I might oopsie and not find the true factors here. All right, I take down the 4. 4 times 1 gives me 4, and I add. 4 times 1 gives me 4, and I get 1. 1 times 1 gets 1, and I lucked out, y'all. Okay, I always start with 1. I'm like, let's just see. But we got lucky here. So one of my factors has to be x minus 1, since x equals 1 is a 0. And then my other terms must be 4x squared plus 4x plus 1 as my other factor. All right, and I want to find the zeros. All right, so I'm going to do that by setting each and every piece equal to 0. Well, I already know that this is going to be x equals 1, but I'm going to have to factor this over here. So I need 2 numbers that multiply to 4 and also add to 4. Well, that's going to be 2 and 2. And then I'm going to choose to do my x box. Or not my x box, my box here. So I'm going to factor out a 2x plus 1. I'm going to factor out a 2x plus 1. Ooh, I have a double root. I have a multiplicity of 2 on that root right there. Let me give me a little more room to write. All right, so I have x plus 2x plus 1, squared must be equal to 0. And when I do that inside piece, I get a negative 1/2. And I'm going to write to the side that that has a multiplicity of 2. All right, let's sketch. It didn't say to sketch, but let's go ahead and do that just so that we have that all in the notes here. All right, here I have a multiplicity of 2. I have a 0 at 1. It's a cubic function with positive coefficient. So I must have a bounce here and then go back up like so.